At this stage, we would like to get rid of sending whole sequences in the accept phase. The leader needs to synchronize its state with the state of the replicas. This is done in the first accept, which we give it a special name, which we call it AcceptSync. Once the replicas are synchronized, in later accepts, the leader can send commands incrementally, one at a time. So let us see our situation now. After sending a prepare, the leader gets promises from a majority of acceptors. At this stage, he can synchronize with those replicas in the majority, and that's what we call the first accept. On the other hand, we cannot synchronize his state with other replicas since he does not know their decided sequence yet. And this can lead later to what we call a later promise. This is a later promise. It's only when he gets this later promise he can synchronize his state with that late follower. So this is the basic idea. So again, after getting the promise messages from a majority, the leader updates its state of its accepted sequence. So now he can get an accepted sequence. Now the leader needs to update the accepted sequences of the replicas. This is what we call synchronizing the state of the replicas. As I said, we have two cases. Replica QI, from which L received a promise. This is a replica at this stage, and he is still in the prepare phase. And replicas from which he receives a promise, but he has already moved to the accept phase. But in both cases, we would need to know the length of the decided sequence at each replica. Otherwise, we will not be able to synchronize efficiently. So what we have done now is that the first accept is a special one because it synchronizes the state of the replicas to reflect the state of the leader. So we have changed now the name of the first accept. We call it AcceptSync. This can happen here for replicas in the majority after the prepare, and it can also happen later when a promise comes late from a follower, so it can happen here again. And this is our focus right now. So we call the first AcceptSync, and we extend the state of the follower to distinguish the first accept from subsequent accept. So a follower comes in initially, and he's a follower, and there is some undefined attribute of the follower yet here. Then he gets a prepare from the leader, so he moves to be a follower in the prepare phase. So a follower in the prepare phase will expect an AcceptSync. And once he gets an AcceptSync, then the follower can move to the accept phase. And in that phase, he is getting commands incrementally. So we are sending an AcceptSync, and the leader is in the prepare phase. So the leader has acquired the knowledge of the length of the decided sequence from majority of replicas through the promise, as we know that. And that happens because each replica Q sends the length of its decided sequence, so LD in the promise. And we know after getting a majority, the leader constructs his own accepted sequence. We have seen that. Now, for each replica in the majority, L sends an accept message, and what this accept message does, for that specific replica, it knows the length of the decided sequence, and that decided sequence is everywhere, it is chosen. Therefore, it just needs to send a suffix of its own accepted sequence that starts after the length of the decided sequence at that replica. And of course, it needs to send the information that index the length of the decided sequence at Q, so that the replica now can augment its accepted sequence at this position with that suffix. This should be clear. So now let us see the code again. We have seen this before. When a replica gets the length of the decided sequence at the leader, it will send any suffix starting from the point in the sequence that is after that decided sequence at the leader. And it will send its own index of what has been decided so far at the replica. Now we are interested of what do we send in the AcceptSync. So let us look now what we do when we get a promise. When we get a promise and we are in the prepare phase from a replica, what did we get? We get the replica's length of a decided sequence. We have this variable, which is a map from a replica to the current length of its decided sequence. We got that. And we got the pair, which is the round it has accepted and the suffix of a sequence that has accepted that round. And as we do before, we collect a majority and we pick the max suffix with the max round number. And that suffix is now interesting. And now we can construct the set of the accepted sequence at the leader. It starts with a prefix with the length of its own decided sequence, followed by the suffix, and followed by any commands that has been proposed while the leader is in the prepare phase. The leader then updates the length of its accepted sequence here. This will be used to know if a sequence is chosen or not. So this is for selecting chosen sequences. The leader moves to a leader accept state, and it sends now AcceptSync message to all replicas that it got information from. So it just looks to this map of decided sequence and see from which replicas I got. And if I got something from that replica, then I send specifically to that replica the suffix of the leader's accepted sequence after that decided index at the replica. And it sends the decided index at the replica. So that's what it does. So this, we will see it by example, but it's basically saying here that replica told me what is its own decided sequence, and I'm going to give it all the elements that I know that should be accepted after it's part of the sequence that is decided. And you can see this then when we look what happened when a replica gets this AcceptSync. So when a replica gets its AcceptSync, it has this suffix and it has this decided sequence, the LD, that it sent before, and that replica is in a follower prepare state. Then it sees if it got this from the current leader. This is defined what is the current leader. It sets the round of its accepted sequence to the round of the current leader, and then it takes the prefix of its accepted sequence up to the decided sequence that it has and augmented with a suffix it got from the leader. At this stage, the accepted sequence at that replica is the same as the accepted sequence when the leader sent the AcceptSync message. And in this case, it just sent that acknowledge the acceptance, and it says now here is the length of what I have accepted. And it moves to being a follower in the accept phase. A follower in the accept phase is going to get commands incrementally, and it will just append it to its accepted sequence. That's it. So let us see this by examples now. And we remember this example, we're going to take it slowly so that everything is clear. Assume that P1 becomes the leader at round 3. We did that before, if you remember, when it became the leader at round 3, and assume that it consulted P2. When it did that, it adopted this sequence from P2, and in fact it adopted it by just accepting this part from P2. It knows that it has C1, the sequence C1 as decided. So we know that. And then it augmented its sequence with local commands. So that is now, at this stage, is the VA of the leader, which is P1. It is here. Now it sends to the replica P2 information that it has after the prefix which is decided at P2. So what is the prefix which is decided at P2? At P2 we know that this part is decided because there is a majority, and that is this thing, and then it sends also the suffix then. So what is the suffix that it sends? It would be, in this case, the suffix, we know the suffix would be this part. That will be sent to P2. Okay, we did that. That was the suffix. And then P2 reconstructs its accepted sequence by saying, where is my decided sequence? It is this part. I will augment it with this thing. And now I get that complete sequence, this sequence. It took its decided sequence, it got the rest from the leader and augmented it here. And now that is a sequence at the follower P2. As you can see, the leader and the follower have now the same synchronized sequences. Now, you might say, P2 has already sent this information to the leader, so why it's getting it back? In fact, this could be optimized when we're doing the function max, when we try to adopt a sequence, by just tracking what was the max sequence and from where it came. But we just, for simplicity, we don't do it. So let us take another example here with the same idea. We have, again, P1 is the leader. It is the leader here. And now, instead of picking P2, it picked P3 and it extended it. So that's what it has now. So now this element does not exist because it have chosen P3 instead. In this case, again, it will actually only send the local commands here. So it will send the local commands to P3 because it knows it has to send information to P3 after the index 2. This is the index here. So that's the decided sequence at P3. And therefore now P3 can just reconstruct its own sequence by just augmenting this little part. And that's what it did here. And that's what we see here. I guess this is fine. Here is another example where the leader is actually P2. So P2 has this sequence. It is a leader here. And after consulting a majority, in this case it consults P1, it gets really no information from them, except it knows what is decided at P1. And what is decided at P1 is this thing. So in this case, it has to send to P1 in the AcceptSync all this information and then say, look, you have only decided at index 1. You can augment your sequence after index 1 with this thing. And in this case, P1 reconstruct the sequence again.